Hi and welcome to this lecture where we'll go into coding part of CRUD operations. So you see my Visual Studio Code now. I have a empty folder called SQL and I will open a new terminal here. So basically here we won't take a data set from anywhere. Instead we will create our own data. So let's start with DuckDB glossary.duckdb. So when I do this, I just do a test to see that yes, we have this glossary here, and I will just do Control D to shut down the database. So basically, this is what I need, and I will save this one, and I will go into dbeaver. I will shut down all others, and I will open file, open project from file system, directory, CRUD operations, like this. And then I will go into CRUD operations, and I will open a connection here, DuckDB connection. I will connect to glossary.duckdb. So right now I double click it so that we see the check mark. So go into SQL here, and from the SQL we will create. So in CRUD operations we have a create, read, update, and delete. We'll go through all of them. And first of all, we need to create a table. So let's create a new script and call it here create statement. So we need to create several tables actually. So let's do like this: create schema if not exists database. So now we have a database schema, and I will copy this again. For example, if I didn't have not exist, let's see what happens. Create schema database. You see that there's an error because they say schema with name database already exists. So that's why I've used if not exist, so that it becomes idempotent. So I can run this how many times as I want. So I run this again and I run it again, and we see nothing changes. So now let's do like this. We create another schema, not exists programming. So basically what I want to do, I want to have several schemas, I want to have several tables, and I would want to put in different glossaries in each of them. So different tables of glossaries. So we can check the schemas we have. So select star from information schema.schemata. So like this, we see all the schemas we have. We have this database schema, we have this programming schema, right? And all others are by default the schemas that exist. So basically what is a schema? Well, it's a logical grouping of database objects. So we want to group our database objects, and more for this lecture we want to group the different tables. So I want to have database related tables inside of database schema. For example, SQL, NoSQL, etc. Or DuckDB, I put into database schema, Python, Java, C#, I put into the programming schema. So we have checked the schemas. And also I want to show you something called sequence. So create a sequence. So create sequence if not exists, id SQL sequence, start 1. Okay, what does this mean? Well, it means that this is a sequence. It starts with 1, and I can make it, it will auto increment, so I can take the next value of this one each time that I create a row in a table. So the idea is that we will, when we create new rows in a table, we don't want to manually enter the ID. So let's copy this one. Copy this one a few times. We started one here as well, and I want to have instead of SQL now ID Python sequence, and I want to make a, let's see, DuckDB sequence. Okay, I run this one and I run this one. And in order to check all the sequences that we have select star from, if you remember with information schemata.schemata, we have some other schemas, right? One of them is PG catalog. So from in PG catalog, we want to select the PG sequences like this. And you can see all the sequences that exist. We see the start value, we see the min value, we see the max value, and we see increment by 1. And if we scroll here, we can also see, let's see, we see last value is null. Whenever you increment this, you will see the last value here. So this is where our sequences live, so that you can look at them if you want. But now it's time for us to create some tables. So create table if not exists. So I use the namespace database.sql because that's where I want to put my SQL table inside of the database schema. So I use this not fully qualified name, but namespace. So what do I want to put into here? Well, I want to put in the ID, and I want it to be integer. I want it to be default next val. I want it to have ID SQL sequence. So basically, I want it to be by default. If I don't put in an integer, explicit integer for ID, then I want it to be default the next value of my sequence. So first, when I create one row, it will be 1. If I create the next row, it will be 2, etc. So this is what I want, the ID column, and then I want to have a word column, and I want to put it as string. I knew I've used varchar before, but you can use string, you can use varchar, and you can use text. They're synonymous, unless you use varchar for certain amount of length if you want to limit the length. But I don't want to do that, so I use string. So description, string. So basically a glossary. I want to just have a word and a description. And then the ID is incrementing by itself. So I do semicolon, and then I run this one, and it seemed to work. I copy this one 2 times. So now I want to have DuckDB. I want this to be DuckDB. So DuckDB I want to be in database as well, but for this one I want to be in programming, and I want to have Python. This should be Python sequence, like this. So I run this one and I run this one. Perfect. So let's check that it works. So select. We can actually go up again. We can copy this one. And instead of information schema and schemata, we can do the tables. And we can see the tables that we have. Well, we have table name DuckDB, SQL, and Python. They live inside of database, and programming. Okay, now let's create another script called, I will mark this one, and I'll create another script, and I'll change the name of it. I will call this one CRUD rate insert.sql, and note that it's the create of the CRUD operations. So this is the create part of the CRUD operation. So then you wonder, maybe why didn't we have the create part before, since we used the create keyword? That isn't actually isn't part of the CRUD operations at all. Instead, CRUD operations refer to the data management part. So data manipulations. So we're using insert. We insert values into the database. When we read CSV files, read CSV auto, then we're doing create in the sense of CRUD operations. So let's insert some data. So insert into database.sql. And what type of columns I want to put into? I want to put into word and description. Note that as the ID is by default the next value of the sequence, I don't need to specify it unless I want to put in explicit IDs, which I do not want to right now. So what I want to put in, I want to put in values, and I want to put in query. What does this mean? Well, it means so much as request. Actually, I can copy. You don't need to see me type it in. Just copy in what it means. Request made to a database to retrieve, modify, or manipulate data. Yes, that sounds good. Like this, and I will run this one, and we see that it worked. How do I know that it works? Well, let's do a select. Select star from database.sql. Like this, and you can see that, yeah, it worked, and it also has the ID 1. Okay, let's continue a little bit, and I will use the same. Database. I will use the same SQL, so the same table, and I copy paste this from the lecture notes, so you can copy it as well. You just need to understand how to do the insert into. And then we just put in some more values. So I run this one. And then if I run this one, we should have 3, right? We have query, CRUD, and we have range conditioned. Okay, let's continue a little bit more. And this one I can copy and paste as well. I can actually leave the select statements down there. So I run this one. Now we go into programming Python. And we see here we put in class, right? Okay, so I go into, well, I can actually copy this one as well. Programming.python. Like this, and we can see that it works as well. And I will insert something to DuckDB. Okay, yes, this was long, actually quite many. So I run this one. We can paste this one, and we do not programming, but database DuckDB. Okay, so we get we get from the DuckDB database. Okay, so this here with the select statements is basically read operations, right? So we do read operations using select. So I'll just move this into another script. So let's see here. We create another script. Create another script here. We change name to to_CRUD_read. Read.sql, right? And then I put this into here. This is the read part, and then we create another one. Change name on this one. And we have free underscore. So it's time for update. So CRUD underscore update.sql, and I will create a new one while I'm at it. So we have for_CRUD delete.sql. So actually, I think, yeah, it got into here. Oh, this is quite tedious. Okay, we close this down. Or actually, okay, since I closed it down, it didn't save. So I need to create them again. Oh, tedious. That's because I didn't put in anything into these scripts. So let's do one by one. So free, we have done CRUD, right? We CRUD update .sql and update. Okay, let's just do this, just to have something here. And we create the next one. We can create CRUD CRUD delete. Okay, yes, perfect. And I want to add another one as well. I will call this alter. Alter.sql. And actually I will start with this alter. And basically I want to alter my DuckDB database and my DuckDB table and add a column. And because when I'm studying glossary, I want to know if I have learned it or not. So I want it to be true or false. So alter table database.duckdb. How do I want to alter it? Well, I want to add a column. I'll call this learned boolean, and default is false. Okay, I run this one, and now I've altered this one. So if I go back to read, for example, and I do read on this one, we can see that, we have, here we have learned, which is empty, right? So it looks like it's empty, but this means that it's false. This is just how it looks like in the Beaver graphically. Let me check the table here, how it looks like. If we go into glossary here, we look into database, we look into tables, DuckDB, double click this one. Yeah, I think it might, yeah, it looks like this. But if you're inside of, for example, if you're inside of the CLI, you'll see how it looks like. DuckDB, or actually I cannot because we have a .val file here. We can go back here and disconnect this database. Disconnect it. So I go back to Visual Studio Code. We see that the write-ahead log has disappeared. So we can do DuckDB glossary of DuckDB, and then we can do select star from, what was it called? It was called database.duckdb. Let's see, misspell like this. Okay, and you see that the learned is false. So that is just the this is the true representation. The data type is Boolean. However, in the Beaver they represented it graphically with empty brackets if it's false, and if it's true, they probably have an X there. We'll see. I guess we'll make some of them true now. So let's do Control D here, or Control C if you're in Windows, and go back to the Beaver. So in the Beaver, let's do some updates. So let's select. Oh, I need to connect this again. So I just double click it and it connects. Select star from database.duckdb. Run this one, and let's see that I have learned what ID 3. I know what varchar is. ID 6. I know what create table is. ID 7. I know what drop schema is. Yes, this is what I've learned. Let's say that. So update database.duckdb set learned to true. Set learned equals true, where ID in 367. So I run this one, and then I run back the select star, and we can see that, okay, V is the checking that it's true, that we've learned this. Great, great. So now you have done update, and what's left is delete. So let's go into the delete part. And let's do select star from, or let's do like this. We go back to insert. Yeah, exactly, insert, and we run this one again. So the Python part. Let's run this again. So it means that now we have two rows that are the same but different IDs, right? So we go back to delete, select star from programming, and we can see that, oh, we cannot take just programming because it doesn't live in main. Instead, we need to do database dot it's programming dot Python, like this. So we see that we have two that are the same, okay, but we do where ID equals 2. And we can see that, yes, this is exactly the row that we want to delete. So to be safe, we start with selecting what we want to delete, and we do delete from programming.python where ID equals 2. Run this one, and if I run this one in here, we get nothing because we have deleted the second row. And if I just run this part, I can actually just mark it and run it. We still get the first row, which is great. Okay, let's sabotage something else. Let's go into our insert, and let's run this DuckDB thing again. We insert again. So we go back to delete, and we do select star from database.duckdb. And we can see here we have 20, and the ones from 11 to 20 are just copies. So we want to remove those, right? So select star from database.duckdb where ID larger than 10. So this we want to remove. So then we just delete from database.duckdb where ID larger than 10. And if I run this statement again, select star from database.duckdb, we can see that we only have 1 to 10. Perfect. So this ends the delete part. So we have done the CRUD operations. We have done some DDL as well, data definition language, like create statement, alter statement, and we have done DML, data manipulation language, for inserting, updating, deleting. We have done DQL, which is data querying using select statements. So what's left is actually I want to try to drop some tables. So this is part of DDL, so data definition language. It's not the delete instance of CRUD. But let's create another script here. We call it drop. So let's do like this. We can drop table database.sql. I want to drop this one. So this means it disappeared. So if I do select star from information schema dot schema dot tables, we can see that, yeah, it has disappeared. However, if I copy this one and I do information schema dot schemata, we can see that we still have the database schema. Okay, that is good. We want to drop another one. We want to drop, let's drop a schema. Drop schema database dots, or actually I want to drop the schema programming. Okay, it says it cannot because, some entries depend on it because it has the Python table, right? So what it says is use drop cascade. Okay, it's actually like this. So drop schema cascade. So drop schema programming cascade. So this will drop the schema and everything inside of it. So if I do select star from information schema.schema and .schemata, we only have the database. We don't have the programming. If I run this one, yes, we don't have the programming table anymore. Or the Python table. We don't have the programming schema. Great. And with this, I'd like to thank, or there's actually one more thing we need to do. We need to disconnect this one in order to get the database to be saved. So if you look into this one, you can actually do DuckDB glossary.duckdb. And if you do test, for example, you can see, yes, we only have the DuckDB table in the database schema. And I'll do Control D to exit this one as well. Yes, and thank you for watching this video on CRUD operations. See you in the next one. Bye.